We're now going to solve a quadratic equation in which the answers are complex numbers. So I'll put one up here. 2x squared plus 3x plus 4 equals to 0. And the process of solving is identical to solving the other quadratic equations that you've seen. But what's going to be different for us here is in computing the decimal answers. It's a different process, computing the decimal answer on a complex number solution versus the real number solutions you've seen earlier. So have to pay attention to that. Okay, well, it's in descending powers, and so our coefficients are in order here. A is equal to 2, b equals to 3, c equals to 4. And so the quadratic formula says that x equals to minus b plus or minus square root of b squared minus 4 times a times c. And everything is divided by 2a. Now under the square root, 3 squared is 9. And 4 times 2 times 4 is, 32. So I have 9 minus 32, which is negative 23. So I'll write this out. X would be negative 3 plus or minus the square root of negative 23 over 4. Now, as you've seen by now, it's customary to write this complex number using the letter I. Square root of a negative, you always factor out letter I. And so this would become, and I'm going to write it down here in the final exact form. So our final exact symbolic answer will be x equals to negative 3 plus or minus I times the square root of 23, all divided by 4. Now you might wonder, why put the I on the left side of the square root? And why wouldn't you just put it on the right side? Well, it's not wrong to put I to the right of the square root of 23. But I found that when I would do that in class, that a lot of students would write them wrong, would make errors with this. So let me show you the error that people can make with this. So here's one to avoid. If you were to write it as x equals to negative 3 plus or minus the square root of 23i over 4. Now what's wrong is the fact that the I is under the square root sign. And the square root of I is not the same as I. When you put it under the square root, you have created a new number. As a matter of fact, if you're wondering what the square root of I is, this is what it is. The square root of I is a complex number. It's going to be the square root of 2 plus I times the square root of 2 over 2. So you don't need to know this, but when you leave I under the square root, then you've created this new number on top of the other mess you have, and now it becomes just totally screwed up. So don't do that. So my way of avoiding that error and students learning this is to get everybody in the habit of putting I on the left side of the square root. Alright, so we have our answer, and you cannot simplify the square root of 23 anymore. So this is our exact symbolic answer. Now I want to discuss calculating this in terms of decimal approximations. So first of all, let me run this by you. Would you ever do this? And I suspect it would be no. Is 1 plus 2i equal to 3i? I hope you say no, because why? These are unlike terms. 1 plus 2i, they're not like numbers. It's not the same as 3i. You cannot combine these at all, so that would be wrong. So that would be combining wrong numbers. Now, I don't, I have probably no students, practically no students who would ever do this. But about half my students will do it when there's decimals involved. They just don't see it very clearly. And so I want to impress upon you that that's a big error in computation. It's one of the reasons I require a numerical computation, just to make sure people are not just blindly putting numbers down there. All right, so let's see how we can do this. Now we can't combine these numbers up here at all, since they're unlike numbers. So I'm going to split this up. X equals to negative 3/4 plus or minus the square root of 23 over 4 times I. Now here I put I on the right side, but it's to the right side of the entire fraction, which is fine. This is the coefficient, the numerical coefficient of letter I. Now in breaking it up this way, we have a real part and an imaginary part. And like you saw before, when I had 1 plus 2i up here, these will not combine together, because here's a real number, here's a different type of number, an imaginary number. They do not mix. All right, so let's calculate this. Now, I usually like to go 3 decimal places, and that's purely arbitrary. But on numbers this size, that's a fairly accurate answer, because it turns in usually to around 3 or 4 significant places. So x is approximately, and I'm going to draw my approximate sign a little better here, hopefully. A little wavy equal sign means approximately. Negative 3/4 is minus 0.75. And then since we're rounding to 3 places, I'm going to put 750 so the reader would know that we did 3 decimals here. Plus or minus, and now let's calculate the square root of 23 over 4. And I get, let's see, rounds off to 1.199. So this one actually rounded up in the last decimal place. Nope, I wrote that wrong. This is 199. 1.199. Okay, there we go. So times I, letter I. So there we go. There are two answers here. It's this decimal plus that number, and this decimal minus that number, provide us the 2 different answers that we would expect from solving a quadratic equation. But here's our approximate answer in decimal form. Notice that I'm not going to attempt to add these together. All right, we can't add those together. But I'm telling you, this is a mistake about half the students in this class will make, unless they take this seriously and remember this issue. So I see this all the time, and I'm just trying to warn you in advance, so some of you will hopefully pay attention and not do that screw up. So, all right, so there's our answer.